All objects have a natural frequency of vibration. You can make an object vibrate at its natural frequency by striking it, plucking it, or blowing over it. However, that's not the only way to make an object vibrate at its natural frequency. We can also get it to vibrate at its natural frequency by sending in vibrations that match that natural frequency. We call this phenomenon resonance. Resonance is inducing the vibrations by sending in vibrations that match it. In front of me is a simple device I made a few years ago to demonstrate this. Think of these as inverted pendulums. You've got a coat hanger wire with a heavy steel washer on top of it, and they all vibrate at a natural rate. Notice the shorter they are, the more rapid their vibration rate is. Well, I can make them vibrate at the natural rate by plucking it, or I can send in vibrations that match it. So I'm going to get them all fairly still, and I'm going to just move the platform back and forth and try to match one of them's natural frequency of vibration. So here we go. So the vibrations that I'm sending in match the natural frequency of vibration of this medium-sized yellow one. So it builds in amplitude as it resonates, and the others are left virtually untouched. If I change my frequency of vibration, I can make a different one vibrate. There goes the smallest one. Or if I make my vibration rate fairly low, I can make the tall pink one resonate. This is why sometimes during earthquakes, one building might be shaken apart and collapse while buildings right next to it are unharmed. So whenever skyscrapers are built in earthquake-prone regions, they have to be careful to take measures so that earthquakes wouldn't vibrate the building at its natural rate and cause them to shake apart. Now we can also do this with tuning forks. You can take a couple of the regular small size tuning forks that are used in lots of classrooms. Get two of them that have the exact same frequency, so they match. And I'm going to use two 512 hertz tuning forks. That's the high C, 1 octave up from middle C. I'm going to strike one of them. I'm going to place its base on the tabletop in front of me. The other one will be placed on the tabletop. And as vibrations from the one that I strike go through the air and through the table, they cause the other tuning fork to vibrate at its natural rate, which matches it, and it will actually build in amplitude, but it is quite faint, and you only hear it if you hold it up to your ear. So this is not really good for say a big class demonstration, but if students have their own tuning forks, they can do this on their own. So I'll strike this one. Vibrations are going through the air and through the table to the other tuning fork. And when I hold it up to my ear, I can hear it faintly vibrating. So a better way to demonstrate this is to use two large tuning forks with sounding boards, sounding boxes. So these are much, much louder, and when I strike this one and the vibrations go through the air, they make this one start vibrating at its natural rate, and it will vibrate with a large enough amplitude that you will be able to hear it on this video clip. So the vibrations are going. I'm going to stop this one. But I can hear this one quite easily. This phenomenon is called resonance. The first time you probably encountered resonance was when you were learning how to swing. Early on in life, you would get in the swing, your parents or someone would push you, and they would make you go. Eventually, the parents get tired of pushing the child, and you say, make yourself swing. And usually the kid just starts jerking back and forth, and nothing happens. But through trial and error, the young child will learn to shift your body weight at just the right time to match the natural swing rate of that swing. That's what resonance is.